So this is the clutch lever off of my buddy's 1937 John Deere Model A tractor. It's a hand-activated clutch. So there's a ball up here where you would use your hand, and this lever would pivot on this bolt. So this shoulder bolt would go through this arm, and this section here that's knurled would go into a hole on the large casting on the side of the tractor. So here I got a picture of a different lever on a John Deere. This is what it looks like when it's bolted together on the tractor. So on the tractor my buddy's working on, this bushing was wore out almost to where it was hitting the metal instead of the bushing. And in order to change that, you got to get this shoulder bolt out of that casting. Well, there's knurls in here. This is actually a reproduction bolt, because he had to cut the other bolt out of there to get the handle off. So when he had to cut this bolt, of course the saw got into the edge a little bit there and tried to clean it up on a sander, which did a pretty nice job, but it's not quite parallel. So we're going to try to make these sides parallel. And since neither one of them is really a good reference point for staying square and true to the hole, I want to machine these faces so that they're square with that hole. So to get started, he already pressed the old bushing out, and I pressed the new replacement bushing in here. And the next thing I have to do is ream this bushing to size, because when you press your bushing in, now it's undersized. So this pin, which should go through that bushing all the way, doesn't fit yet. So this is a casting. There's not really a good surface on here to use as a reference surface. How are you going to line up with that hole? Well, I got this 3/4 inch shaft. I think I cut it out of a wheel horse lift lever. And I turned 10 thousandths off the end of this to match this bushing diameter. Now it's still undersized, but I made this specially to fit that undersized bushing just for this setup. So I'm going to try to locate it in the vise. And I'm going to have this shaft in my collet. So I can move this handle around and find where the correct position is to clamp that. So I have some aluminum here. I'm going to use the aluminum against the casting. I'm going to move the table, or the vise, which is the back jaw, stays fixed to the table. I move that away, and I can bring it up against the part by moving the table backwards. Then this front jaw I'll use to clamp against this side of the part. So when I have this clamped in here, it's pretty close to being in the right place. When I snug up the vise, I can't pull this pin back out. So it's binding in there somehow. So I'm going to move the setup around a little bit, see what I can do. Okay, it's still binding up in there. This casting looks like it's sticking out at the bottom a little bit on that side. So when I tighten the vise, it tilts it back. So this shim is above the bump in the casting now. And I'm going to put this shim directly opposite at about the same height. We'll see if we can try it there. Wow, that's pretty nice there. So I'm not going to move it anymore. I'm surprised it came out that nicely with this setup. I'm going to tighten the vise, make sure it's tight enough to do what I want to do. And that's still pretty darn good. I'm surprised. Okay, so we know where the hole is. Now I had a spacer down here just to make sure I was not bottomed out, because I need the reamer or boring bar, whichever I decide to use, to go all the way through this part. So that's pretty nice there. I'm going to lock my table down. Okay, everything's tight. The vise is tight and the table's locked down in that position. So the next thing I'm going to do is finish this bore to size to fit this bolt. Now this bolt measures 2/1000 undersize on this part of the shank. This is about 7/48. And they expect to use that with a 3/4 inch hole, which is 750 or 750 thousandths. So it touched in this corner first, and it took 20 thousandths to get it to clean up down to this corner. A little more than I expected. And I made sure that I cut into the aluminum parallels with the end mill so that I went past the edge of the part. That's a pretty snug fit actually, but once it gets down in there, then it turns freely. So I need to polish this bolt a little bit right in this area. Alright, that feels pretty nice there. A little bit on this corner is all that's left. I'm going to stop here. Okay, let's see how we did here. So this is an inch, 436. $435 3/4, so it's 1 1/4 thousandths out of parallel. Everything feels really good there. So the next process is I'm going to make a little spacer, so I need to measure this thickness and measure the length of this shoulder, and we'll determine what size of a spacer washer to make so that it don't have very much side play either. What I made here is a washer. I just need to cut it off to the right thickness. So this is a cutoff tool, and what I'm doing here is establishing the right side of the cutoff tool as being flush with the end of the part. On this machine I have a travel dial, which tells me how far the carriage travels when I move it. Once I have the right side of the tool flush with the end of the part, I can zero this dial, and then I move the carriage by the thickness that I want the washer to be, and that's where I'm going to cut it. Before I cut this off all the way, I can use this other tool to put a chamfer on each side of the washer. Using the travel dial, I can put this cutoff tool right back where it was and continue the cutoff operation. I want to deburr the inside edges of this washer, so I'm going to put it on the outside tips of these jaws so that the washer overhangs a little bit, and I'm going to use this plate to push it back flush with the face of the jaws. So that'll just help it run true. This is what the handle looks like installed on the tractor. You can see the spacer in there between the handle and the casting. The clutch arm is not on there because we're working on what's on the other end of it. Alright, that's it.